All right, so welcome everyone. Thank you for joining my presentation. Today I will speak with you about how you can supercharge your Flutter declarative UI using codegeneration. Let me briefly introduce myself. My name is Emanuele. I'm an Android developer from Italy, and I'm currently working at Zest1, a mobile-oriented company in Switzerland. And I recently started working on Flutter because we have several different projects, so we wanted to experiment something new. And I'm trying to make a change in what I do, even if I still say I'm an Android developer, because at the moment I still like Android native. So what I want to starting speaking today about is the declarative UI. You probably know what it is because you're probably a Flutter developer or Android or iOS maybe. So you know what's the point. And actually, the focus of this concept is that with the declarative UI, we don't write anymore XML or UI kit, but what we do is that we write the UI with the same language we write the business logic. So this means that the same tools, the same techniques used for the business logic can be used for the UI. In this case, I'm speaking about annotation processing, which is what we are going to see today. Unfortunately, I think the Flutter UI is not perfect yet, so I try to improve it in some way, which I found it was not perfect for me. In this slide, what you see is an example of how you can add the padding in Flutter. So here we add the padding of 16 to all the edges of a text view. And you probably know what I'm doing here, because this is the probably most common example you see online in the documentation. And the first time I was writing this, I was quite confused because I didn't know about edge insets. And since the parameter name is padding, I was expecting to type something like padding and then add the value of 16. So it's okay you look at the documentation the first time because you don't know things. But it's not okay if you look at it every time you need to write a piece of code, or if you need to go back looking at the code you already wrote to know what you need to write. So this is because what I want, and probably what everyone wants, is code that is easy to write. You don't need to check the documentation every time. We want to avoid errors caused by destruction. You want to minimize boilerplate, code duplication. And because we use an IDE, we want it to be the most powerful it can, because we want to improve our productivity. So I started looking online for improvements because I want to don't write edge insets anymore. Actually, on GitHub, there are some libraries that try to tackle this issue. So I was not the only one. And this made me comfortable because I didn't think anymore that it was an issue that I only had, because also other people was experiencing the same struggle. And so now, today, I want to show you what I did to solve this issue and what's already available, and maybe how you can create something similar for any issue you can have. So one of the library I found on GitHub was providing a set of already made widgets, like padding top in the example here, where you just need to pass two parameters, 16, which is the value of the padding, and the child widget, where you want to apply the padding to. Of course, this is an improvement over the standard solution, because you don't need to write edge insets anymore, all that boilerplate, but you still need to write the padding value. 16 here can also be a constant that you can define somewhere in your code. So this is not the point, because even if you write the constant, you still need to add it here. And this is not what I wanted. I wanted something that could match my design system, so I can define all the padding values somewhere and then reuse them. So the solution I wanted to came up was something like this: medium padding, medium top padding. If we assume that 16 is the value of the medium padding in our design system, this widget, if you read its name, you know what it does, because it just adds medium padding to the top of the child widget. So here, we don't need to write the 16 or the padding medium constant manually. We can just use the widget and know what it does just reading these few lines of code. Obviously, we have different sizes for padding, and we have different possibilities, different edges where we can add the padding to our widgets. So how can I create these widgets? Because obviously I cannot create them manually, and even if I want to spend some time creating them, then it will be hard when I need to maintain all of them, because the design system can change or whatever. So it will be impossible to maintain all this stuff, all this code. That's why I created this library, Paddinger, which is already available on PubDev, and so you can already use it in your projects. And it's already also available on GitHub. So if you want to check its source code, make a fork or improve it, or just taking inspiration, you can go on GitHub and check its source code, or we will check it later in this presentation. First, let's see how Paddinger works, so how you can use it in your projects. First of all, obviously, you need to add Paddinger to your dependencies. So in your pub spec file, you should add Paddinger annotations and Paddinger to projects. And this is because in this way, I can make a better separation of what I need in the different projects. And also, I don't want to ship in the final artifact the code that is used to make the widgets, because it doesn't make any sense for the user to have it. So I can add it as a dev dependency that is not shipped in the final artifact. But we will check it later when I explain how the project is made. Then what you need to do is to create a paddings.dart file, which will contain all the definitions of paddings in your design system. So here, for example, I add padding medium with a value of 16 and padding large with a value of 24. The point here is that both the constants are annotated with @Paddinger, which is the annotation that we use to mark constants for which we want the widgets to be generated. Then, still in this file, you need to add the material or Cupertino import based on the style of your app, because unfortunately at this moment, code generator cannot add import to the generated file, so you need to add it manually. I hope it will be solved by Flutter in the future. And then you need to add the part directive, where you specify the name of the file in which all your widgets will be created, so you can then later check their source code. You don't need actually now to do anything more, but to run the code generation. So when you run the code generation using this command, after a few moments, you will get all the widgets created by SourceGen, which is the library we use to create the widgets. So what we get is this. This is the result of the code generation. And since we specified padding medium and padding large, we will get all these sets of widgets. So for example, for padding medium, we get medium all padding, medium left, medium top, medium right, and so on. All the possible things, all the possible combinations that you can create with edge insets. Let's see one of these classes, how they are made. So for example, here we see medium all padding. Medium all padding is just a class that extends padding and already add the edgeinsets.all for you with the correct value of the padding you want. Nothing special, okay, I know, but when you use it, it's you can just add one line of code instead of all the boilerplate of edgeinsets. So when you want to use them, you can just need to import the paddings.dart file, the file where we specified all the constants, and it will import for you also the paddings.g.dart file, which is the file where the widgets will be generated. And actually, you can just use all the widgets. So with one line of import, you can use all of them. It's very important that you don't add to version control this file, because since this code is generated, you should not edit it manually, because otherwise it will be overwritten every time. And also because your constants can change, so they will be needed to be regenerated all the time. They can change. Now, we have just seen how you can use it in your project, but let's see how it's created, so you can have a better understand of what's under the hood of Paddinger. As I said before, Paddinger is structured as a monorepo project. So there are two projects inside, Paddinger and Paddinger annotations. This is to better separate the logic. So here, in Paddinger annotations, we will keep all the annotation we need to mark our code. Then in this case, actually, it's just at Paddinger and nothing more. While in the Paddinger project, we will keep all the business logic needed to generate the widgets. Let's start first with Paddinger annotations, because it's the simplest one. And actually, this project doesn't have any dependencies at all, because we don't need any of them. The only thing it's contained in this project is this file, where I specify the annotation I want to use. Now, let's have a look at Paddinger, which is a bit more complicated. And let's start with pubspec.yaml. It's a file where we define the dependencies. Here we can see that Paddinger depends on build and sourcegen. There are two Flutter packages that are, their purpose is to make us able to generate other code, to generate other widgets, or maybe also business logic, but in this case, to generate widgets. Then it also depends on Paddinger annotations, because it needs to know which annotation we need to generate the code, to mark the code. And here in this example, I also left some lines commented, because I wanted to tell you that when you write your own library, you probably, obviously, need to make some changes. So you will need to point to a local directory, to a local version of your libraries. So here you can just comment those lines, comment the other one where I specified the version, and you can work with a local copy of the library. So you can make changes, tests, and whatever. Well, when you need to publish the library, PubDev requires your library to only depends on libraries that are already published. So in this case, we always first need to publish Paddinger annotations, and only then we can publish Paddinger, because otherwise we don't find the correct version. Then, of course, Paddinger depends on test, because here we are generating code on which we don't have much control. I mean, it's best, there are a lot of tests are in place, because if you use a library that generates code, you expect that code to be okay, to be good for you. So you should check that libraries that you use have tests, because you rely on them and you never check the generated code to check it's good. Only you probably will only check it when you have a problem. but maybe it's too late. So it's better to check the library first. Then another important file is the build.yaml file, where we tell Flutter that we want to add another generator to the generation phase. So in this case, I say Flutter, I want to add Paddinger generator, which is just a name, so you can name it however you want. And you need to specify the file where it's located with the import line. So when we have a look at it, we see that with these few lines, we just create an instance of our generator, and we don't need to do anything more. This function actually is provided by one of the libraries that we use, build and sourcegen. So you just need to create the instance of the file containing your business logic. This file, where we create the widgets, is this one, Paddinger generator. Paddinger generator is this class that extends generator for annotation, having a generic type of Paddinger, which is the annotation we used before. And it has just one single method, generate for annotated element. This method will be called for each item, for each variable, constant or whatever, you annotated with @Paddinger. So in our example, before we annotated padding medium and padding large, so this method will be called twice. What we do here is first we get the constant name. So for example, for padding medium, we get padding medium as a string. Then we validate, we annotated something which we are expecting the user, the one that is using our library, to annotate. Now, the only thing I put in place is that I want something that starts with padding underscore and nothing more. But of course, you can check that the user can only annotate classes or only methods or only variables. So it's up to you. It's up what you need to do. Then I generate the name I want to use for the widgets. So for example, from padding underscore medium, I get medium. Medium in uppercase, in upper camel case, which will be the prefix I will use for the widgets. And for example, if I use padding very large, in this case I will get very large. That will be the prefix to the widgets. Then in the last line, I will generate all the widgets we saw before. And now we can see how this happens. So this is the method where the widgets are being generated. And since all of them will be generated in a single file for all the possible sizes you annotated, I start and end this piece of code with comments to better organize them. Because maybe you want to have a look at the source code. And even if it is generated, it's better that it's formatted correctly. This is, as you can see, this method returns a string. And this string actually will be inserted in the file we saw before and will be the source code that we can use. So these four methods that you see here, add all padding, add only paddings, and so on, are methods that will return the source code that we can also write manually. So let's see one of these examples. I'll start with add all padding, which is the most simple one. And add all padding, just use the code we saw before, but as a template. So here, for each padding we have in our design system, this code will return the source code for the widgets. So in our example, when we run this source code for padding medium, what we get is medium all padding. And this widget is already ready to be used from us. Another example is add only paddings. Here, now, we need to create 4 different widgets because we have 4 only directions that can be created with edge insets. So I enumerate those directions, top, left, right, and bottom, and then I create the 4 widgets that will be added to the list of the widgets we have. So in our example, where we use padding medium, we will get 4 classes, 4 widgets. Medium left padding, medium top padding, medium right, and medium bottom padding. I skip the other 2 methods, but they do the same. So they will generate the horizontal and vertical, so the 2 symmetric widgets. And then also I generate all the different combinations you can create with edge insets. Because, for example, with edge insets dot only, you can pass as parameter left and top. And so I create these missing combinations, so you have all the widgets. Now we have just seen how you can use Paddinger, how it's created. And I want to show you how you can test the code that it produces. Because as I said before, it's very important you check the code is generated the way you want. So let's start with these 2 simple tests that validate that the user annotated what you expect. So in this case, in the first one, I check that if the user annotates something that's called padding medium, it is valid. So our method returns normally because the user annotated something that we expect, because otherwise we cannot extract the name of the widget that we want to create. In the second test, I just wrote padding medium without a G. So this name is not valid, and I expect my method, my test, to throw an exception. When our generator throws an exception, actually the code generation stops and shows the user an error. So the user can go there, can go check what he did wrong, and can understand and fix the code. And then he can run the generation again. Then another couple of tests to check that from the name of the constants, we get the correct prefix for the widgets we want to create. So here, in the first case, I add a test that checks that from padding medium, I get medium. While in the second test, I check that from padding very large, I get very large. Then, the last test, but probably the most important one, is the one that checks that the code which is generated is correctly. And here, since this method returns a string, we can just write the source code we expect it generates and compare it with the one returned by the method. Of course, here I omitted a lot of stuff, but all the classes will be here in this string, and they need to match what is returned by the test. You can also add more tests. I was experiencing another way of doing this, which is testing that the code you write, the code that is generated actually compiles to something that is good. But you can also just do this and compare the source code. Some things I want to add more that are that if you use this library or something like this, actually, your IDE will become smarter, because when you use edge insets, it's not so able to suggest you all the things you can do, all the things you can write. But now here, since all the classes, all the widgets shares padding in their name, you can just start writing padding, and all the combinations you have will appear in a list. So you can just pick one of them from the list, and you will be faster. Another nice thing is that if you already know what you want to add, for example, in this case, top left medium padding, you can just type TLMP, and the IDE will be so smart to suggest you the class you want. So only typing 4 characters and then enter, you achieve what you want. This might seem a simple thing, but we always want to be faster than we are. So even if we save some seconds for each action we do, will be a lot of time at the end of the day. So we are coming to an end of the presentation. Maybe I was a little fast. I hope every one of you understood the concept. And I hope right now you are asking in your mind, can I generate whatever I want? Can I apply this same technique to something I do every day, which is boilerplate, which I don't want to write anymore, which I hope one of my colleagues write instead of me? And definitely the answer is yes. You can apply this technique to what you want. So I hope I gave you some inspiration. Hopefully, we will see some of new libraries appearing on PubDev thanks to one of you. And I want to say that even if Paddinger looks very simple, it made me able to make this presentation. So I'm happy it is so simple, because I hope every one of you could understand it. And anyway, it improved my productivity. So this is not something that I'm just saying here in the presentation. It really improved my productivity and also the one of my team. And we are very happy to be using it, and we are looking into creating something more similar to this. So thank you very much for listening. I hope you have enjoyed it. And yeah, these are my references. So if you want to get in touch with me, just write to me, and we can have a chat on, I can help you if you want to do something similar. And anyway, if you want to work in Switzerland, you can just drop a line to that email, and we can get in touch. Thank you. Thank you. If anyone has some questions, feel free to ask now, or we can touch. Yeah, actually here I also want to generate all the gene sets combination and not widgets, because there are other widgets in Flutter that accept as a parameter gene sets. So I want to generate all of them, and so you don't need to write the gene sets, even if in those places. I actually already wrote some part of the code, but I didn't publish it on GitHub yet. Yep.
Question regarding the build step with generating the code. So have you looked into automate that? Like any of the steps in your version control or?
You mean with a CI?
So right now, the way you do it, you just run the CLI command.
Yeah. No, but for example, you can add it to, if you use IntelliJ at least. I don't know about Visual Studio Code because I don't use it so much. You can change the run configuration, and you can add all the scripts you want. So you can just put that scripts there. So it will be run every time you run the app. One thing I noticed, unfortunately, is that sometimes he understands you didn't make any change, so it doesn't run, it just runs your app. But sometimes it tries to generate all the things again, so maybe you become slower, because every time it tries to generate even if it doesn't need to. Yeah, you can also use that, yeah. Yeah, also Flutter does has something like that. Yeah, and whenever you change a file, it will run your code in the background and will generate stuff. No, I didn't hear you very well. Last.
Like I've heard some developers really dislike code generation.
Mm-hmm. I don't know. Actually, after I generated something myself the first time, I tried to generate all the things I could, because it will save your time, and you test it once and it works all the time, because the code will be generated by a machine. So it's less prone to error to what we can do. And I don't know why people are against it, but sometimes people are against all the stuff. So you can mess with them. Anyone else? No? Okay. Thank you very much. Thank you very much.